This lesson is about reversed bearing. Another word for, or another name for reversed bearing is back bearing. So if the bearing of a point A is described from another point B, then the bearing of B can be described from A based on the first description. So a better way to explain what reverse bearing is just by treating the example. After I've treated the example, I think I'll draw your mind back to why it's called a reverse bearing. So let's solve solution number one. So we are going into bearing properly. So at this stage and from this point onwards, we're going to be doing a lot with conversion from either compass bearing to 3-digit bearing or from 3-digit bearing to compass bearing. And also, we're going to use a lot of the notes I put on the board in the previous lesson, which was relationship between compass bearing and 3-digit bearing. That the notes that concern transversal and parallel lines, the kinds of angles that are formed when a transversal or transversals cut parallel lines. Okay, so let's begin. So if the bearing of A from O is 050 degrees, the bearing of O from A is, now as we delve into bearing properly, we're going to take note of one key word that's always important whenever we are treating bearing, and that's the word from. This word from. So it is a very key word that determines determines the shape of the bearing we are going to get. If we don't understand the from, we cannot plot the bearing of any point. We cannot plot the bearing of any point. I say it again. So you must understand the word from. Let me make a reference. Now when we say the word from, it tells you where you are starting or where the bearing was plotted. So if let's say let's call Clinton, by example. Clinton wants to move to point A. Clinton is at point A now. He wants to move to point C. Okay, point C, and let's say point B is here. Now, if I want to know, okay, now he wants to, let's assume that initially he was at point A and he wanted to get to point C before going to point B. So let's say about after 2 hours, he had gotten to point C and had also gotten to point B. Now we want to know how the movement went. So we want to know the directions or the direction of movement of Clinton. So how do we put this? So since this is the initial point, what is the direction or what's the bearing of Clinton? If Clinton is facing here, if Clinton is at this point and he wants to get to C, how would the direction look like? So if we put our cardinal point here, which is point A, so which means that the bearing of C from A, so your reference is from A. So if you are the bearing of C from A means that because the word from goes with point A, your plot, the cardinal point you're going to plot concerning this A is going to be at point A. So the cardinal point you're going to plot concerning the direction of Clinton from A to C is going to be from A. So anywhere you see this word from, the point that comes after the from, that's where you are starting, or that's where you're going to plot the bearing. So from A means that, and if it's from A is 36 degrees. So let's say from A, or because what I'm saying here is more than 36 degrees. So let's say 74 degrees. So from A, let's say 74 to meet C. So from here, north to south is either 74 degrees or in compass bearing 74 degrees. So it's still the same thing. So you see that the bearing of C from A is, and then at C you put your cardinal point. So this is a C. So the bearing of A from C is 74 degrees. So that tells you that the movement, the reference was from A, the starting point. So if you get to C and you want to know the direction of Clinton when he started his journey from A, this is how the line of the movement or the direction would look like. This is the angular measurement of the direction. Then from, you want to get the bearing of B from C, the bearing of B from C, then that means since the word from comes immediately after, no, since the word from comes immediately before C, or it follows C rather, you're going to start your plot your bearing or the direction from C, because the word from follows C. So your direction will be from at this point C. So meet this point B to join or link to point B. So from C, if you draw your point to meet it here, sorry, let me draw it accurately. Okay, so here. So if you are going with the north, the 2-digit bearing, then from the north to this line, that's what you're going to do. So whatever that angle is, that's the bearing of B from C. But if the question says the bearing of C from B, it means you're going to plot your direction from the point B. So from B, from the north pole to this line, whatever the angle is, that's the bearing of C from B. So always take note. The key word in bearing is this word from. Always, that's where the reference is. So we don't have problem plotting our direction. I've told you, if you are given 074, you can represent it diagrammatically either with a 3-digit bearing or the compass bearing. So you don't have problem with that. The only thing you need to note here in this topic is this word from, and it's going to be useful from this point onwards. It's going to be useful. So number one, if the bearing of A from O, so take note of this word from what point? O. So our reference is from O. We've got to know the bearing of A from O, from point O. So the first thing to do is to plot point O. And what is from O? The angle 050 degrees. So 050 degrees is going to look like this. It's going to be in the first quadrant, which means it's going to go up. That's why I have to bring this point down. So take note of what your angle is, 50 degrees. If it says 180 or 150, you know that 150 is going to come like this. So which means this point will be a little bit upwards. But in this case, it's 050 degrees, which means it's going to go up. So the next point will be up here. So now let's go. So if the bearing of A from O, so O, this is point O, starting, that's where it started, and then 050 degrees will look like this. So the north is 050 degrees. So this is 3-digit bearing, and where the line ends, that will give you point E. So that's the meaning. Okay, so this is what it implies. This first sentence, the bearing of A from O, so indicate, show 50 degrees in form of in a diagram form. That's what it implies. Show represents 050 degrees in diagram form as point O. Then let it the direction, let it meet point E. Then at point A, draw your compass again and leave it like that. So that then the next part of the question says the bearing of O from A. So now we want to get the bearing of O from A. So what is the bearing of O from A? The bearing of O from A will not be the angular measure from the north. Since this is 3-digit bearing, so we're also going to implement 3-digit bearing here. So from the north to this line again. So you see it. So the north to this line. Now this is where our calculations comes in, and you have to pay attention here. Okay, so before we proceed, you know, when we're working with conversion from 3-digit bearing to compass bearing, it was pretty easy because the figures were given. But now we're only given one figure here, 050 degrees, and we're going to work with that. So this is where what I put as note in the previous lesson comes in. Now when you come here, I told you that in your quadrants, especially the quadrant used for bearing, what you have here is 0 to 90 degrees, and here what you have here is 90 degrees to 180 degrees, and here is 180 degrees to 270 degrees, and here 270 degrees to 360 degrees. So that way, this is your first, this is your second, this is your third, and this is your fourth quadrant. Okay, so now and this being so, from one between north to east is 90 degrees, between east to south is another 90, and another 90, and another 90. So that makes it 360 degrees. So what you have here is that from here to here is 90 degrees, which from here to this line is already 50 degrees. So what will be this angle here? This remaining angle here will be 40 degrees, right? So which means if here's 40 degrees, by alternate angles, here is also 40 degrees. But we don't have any issue with this part. So I just brought it up so that you know the process we go through when we are computing reverse bearing. So why am I bringing up this? I'm doing this because we need to know this angle from here to here, because this is 3-digit bearing, and we already know that from this north to this south is 180 degrees. So 180 degrees, what about from here to this point? So give us the full angle. So if we know here, we add it to 180 degrees, then we can get the bearing of A, the bearing of O from A. So A is equal to A, let me just say, so let's call this one theta. So theta, so this is 180 degrees. So how we go about this is that we can observe that here 50 degrees is alternate to this part. So by alternate angles, this part is also 50 degrees. 50 degrees. So if that part is 50 degrees, and then it follows that 180 degrees from north to the south, 180 degrees plus this 50 degrees will give us the whole of from north to this line. So which will give us theta plus, so theta is equal to 180 degrees plus 50 degrees, and theta is equal to 230 degrees. Theta is 230 degrees. So this tells us that therefore the bearing of O from A is 230 degrees. So this is why it's called reverse bearing. It's called reverse bearing because initially the question says if the bearing of A, so the bearing of A from O is 50 degrees, then the question says, so what is the bearing of O from A? So it's just like back bearing. From a particular point, you got to plot the bearing of another point. Then from that same point again, you got to plot the bearing of the previous point where you started. So that's like reversed. That's why it's called reverse bearing or back bearing. So let's take number 2. Number 2 says, what is the bearing of P from Q if the bearing of Q from P? So from P, let's plot our P. So let's take note of the angle from P. So we're going to start at point P. So and P is 241 degrees. So 241 degrees will be in the third quadrant. So that means if it's in the third quadrant and it's going to come this way. So I'm going to bring my point here. 240. So P, this is P. And then 241 is going to come like this. So from the north pole to this line is going to be 241 degrees. Then where this line will end, it must not be as long as I drew mine, but you know, this is just an example. So you draw your cardinal points, and make sure when you're drawing your cardinal points, make sure you draw it in a way that the line naturally fits into a quadrant. Don't force a quadrant into it. For instance, this line will naturally fall into the first quadrant like this. It can never, if it's from 241, you can't draw it and then it will not be in the third quadrant like this. You see, it was always be in the first quadrant. It can't be in the third quadrant, and it can never be in the fourth quadrant like this. So this is our line, and then you see that this line across this point. No, it can never be in that. Naturally to fall into the first quadrant. So you leave it like that. So once it's there, this is P, and then what's the other point? Q. So this is point Q. So the bearing of Q from P is 241 degrees. Now, what is the bearing of P from Q? So the bearing of P from Q is going to be, so it's not difficult. It's not difficult. So since this is the line, what you do is that you measure your angle from the north pole to the line. Just meet the line. So whatever the angle here is, that's the answer. Now, how do you get to know this angle? It will not be by alternate angle. So let's come here. From the north pole to this line is 241 degrees, of which you already know that from this north pole to the south, from this north to the south is 180 degrees. So what would be this angle? So let's call this angle theta. Now, how do we get this? You know that theta plus 180 degrees is equal to 241 degrees, right? Now, to get theta, now the theta is equal to 241 degrees minus 180 degrees. So we can get this angle. So theta is equal to 241 minus 180 degrees. So 1 minus 0 is 1. 14 minus 8 is 6. Because I have to borrow from here to make it 14. 6. So that's 61 degrees. So now we know here to the 61 degrees, because how we got 241 degrees was 61, which is this angle, plus this from here to here, which is 180, to get 241, which is from here to this line. So theta is 61 degrees. Now, if here is 61 degrees, by alternate angles, this side also be 61 degrees. So therefore, the bearing of P from Q is 61 degrees. That's it. So simple. Number 1. The bearing of a point A from a point B is 0.42 degrees. So point A from a point B, so B is 0.42 0, 42 degrees. E. I always say that anything, take note of this word from. So the point following from is where you are going to start to get the direction, where you're going to get the direction or plot the bearing. Is for to now calculate the bearing of B from A. So and then from A means from the north pole to meet the line, because this is the line connecting A and B. So we'll put it here. Now what do you have here? This point here, and so you see here is B and here is A. So B is equal to 180 degrees, and then A is equal to what? 42 degrees. Why? Alternate angles. So the bearing of B from A is equal to A plus B. That will give us 180 degrees plus 42 degrees. And that will give us 180 plus 42, 222 degrees. 122 degrees. Number 2. Find the bearing of a point X from Y. So X from Y, X from Y, from Y. What is it? If the bearing of Y from X is 110 degrees, the bearing of Y from X 110 will be like this. You see, because 110 degrees, and then Y. So once we get the bearing of X from Y, that will give us. So we need to get E and B. So E is equal to 180 degrees. Y angles on a line. Angles on a line. B is equal to 110 degrees. Y alternate angles. So from the north to the line is alternate from the south to the line. So these two are alternate. Remember, if you have something like this, this is like a transversal. These are parallel lines, and this is transversal, cutting the parallel lines. Then, so this is, so what we have here is 110 degrees, and then what we have here is B. So they are alternate. So take note, it's not from the north to this line, it's from this south, from here to here. That's B. So, and the bearing of X from Y, bearing of X from Y is equal to E plus B. That will give us 180 degrees plus 110 degrees. 290 degrees. 90 degrees. Number 3. Esther was facing south 20 degrees west. Compass here, south 20 degrees west. So from the south pole, this is it, is west, east, north, south. South 20 degrees west. Then she turned 90 degrees in the clockwise direction. Clockwise, like this. So if she turned 90 degrees, let's say, up like this. So 90, that would be what's here, 90 degrees. And you know how we represent 90 degrees? Like this. So that's 90 degrees. So let's say 90, there's 90 degrees in the clockwise direction. Okay, so in clockwise direction, what direction is she facing? What direction is she facing? She's facing not this angle here, and okay, so let's call this angle. This direction she's facing will be gotten when, since this is 3-digit bearing, sorry, this is compass bearing, our measurement will be from the north to the line, just as what we got here is from the south to this line, south 20 degrees west. So now we north, let's call here A, north A degrees west. So A, for us to get A, we need to get B, and then we need to get C. So let's see what that gives us. So from what we have here, 90 degrees will give us, so from here, C is equal to C is equal to, from W to S is 90 degrees, so that's 90 degrees minus 20 degrees. So this remaining angle from here to this line would be 90 degrees minus 20 degrees, which is equal to 70 degrees. So B is equal to, now if from here the whole of here is 90 degrees, so B is equal to B plus C. B plus C is equal to 90 degrees. So B is equal to 90 degrees minus C. So B is equal to 90 degrees. And what is C? C is 70 degrees. B is equal to 20 degrees. Now, if B is equal to 20 degrees, then the north to the west is 90 degrees. That's complementary angles. So C, so this one is equal to complementary angles, and here is sum of angles. So still, okay, from here, just the 90 degrees I was going to us, and then B is equal to 20 degrees. Okay, so now to get A plus B is equal to 90 degrees. Complementary angles, that's this quadrant, this first quadrant, northwest, that's 90 degrees here. So the sum of A plus B is 90 degrees, of which we already know what B is. So A plus B is 20 degrees. A plus 20 degrees is equal to 90 degrees. A is equal to 90 degrees minus 20 degrees. And that A will give us 70 degrees. Therefore, the bearing therefore the direction, okay, therefore the direction she is facing is not 70 degrees west. Number 4. Find the bearing of x from y. So these are diagrams. Not not 60 degrees, 120 degrees. Okay, so the bearing of x from y will give us, this is x, and then this is y. Find the bearing of x from y. So the bearing of x from y will be from the north pole to this line, and that will give us, so let's call here A. Okay, so A will give us A plus 120 degrees is equal to 360 degrees. Y angles at a point. So A is equal to 360 degrees minus 120 degrees. So A is equal to 240 degrees. That's the bearing of A. Therefore the bearing of x from y is equal to 240 degrees. 240 degrees. B says if line xy is 50 meters, how far east of x is y? East of x means from x we go east, and then bring down this down. What's the distance? So let's call here x, y, so z. So the distance between x and z is alpha is of x is. So we are looking for x, z. So if here is 60 degrees, let's get this angle. Remember this is now 90 degrees, so let's call here I've gotten a, let's call here b in this case. So angle b plus 60 degrees equals to 90 degrees. Why? Complementary angles, because this is the first quadrant, so be from the north to east is 90 degrees. So the sum of angles in this quadrant is equal to 90 degrees. That's why they are called complementary angles. Two angles when added will give you 90 degrees. So b is equal to 90 degrees minus 60 degrees. B will give you 30 degrees. Now, since we are looking from this side, and adjacent over 15, distance is 50 kilometers. So the hypotenuse is given. So using the cosine ratio, using the cosine ratio, cos 30 degrees is equal to adjacent, which is x z over hypotenuse 50. So x z is equal to 50 cos 30 degrees. X z equals to 50 cos 30, 43, 0.30 kilometers. Therefore, x y is is 43.30 kilometers east of y.